Now, do you guys see some notes, kind of a revision year 13 linear motion on the screen?
Yeah.
Yeah, okay. So in first part, I've already started recording, so I hope it is recording. But Angelique, if you can start your one, if you are able to start, sometime, only one person can record. That's what I've learned. So if you can start recording now, that will be great. Okay, so first of all, we will look at the collision. And in a collision, there are three principles that are involved in each and every collision. First principle is the total momentum of the system is conserved, as long as there are no external forces. Second rule is that during the collision, change in momentum of one object is equal and opposite to the change in momentum of the other objects. That's the second statement here. And the third statement is that center of mass of the system keeps moving with the same constant velocity. Now, for all these conditions, laws, condition is that there should be no external forces acting on the two objects which are having a collision. So first of all, we will look at from the first point of view at this collision. So in this question, which is the revision sheet, and blue ball is moving in this direction with a certain velocity. All those details are given here, and I've got the answers here, but I will just go through the main concept. The blue ball was stationary, so momentum was only due to this ball. After the collision, they move at 90 degrees angle to one another. We are given, in this question, they've given the speed and direction of this one, but not the speed and direction of that one. I mean, in this one, you can see the direction, but in a question, they might not give you, and you might have to find what will be the speed and direction of this ball. So what we will do is we will apply the law of conservation of momentum. And so first of all, we need to calculate all the momentums that we are given. So initial momentum is m times v. So initial momentum was only due to this ball. So that is the momentum of the system before the collision. According to the law, total momentum of these balls should remain the same, in the same direction, in the same size. So that's the total momentum that we need to draw. Now, we've been given the momentum of the green ball in the information, so we will draw a vector over here. This one wasn't given. So by completing this vector triangle, that gives us that blue ball must have a momentum in this direction, or in other words, the blue ball moves in this direction over here. So using Pythagoras, we can calculate the size of this one, and we can find the exact angle. So that's how we find the momentum of this ball. And once we found the momentum of this ball using the equation P equals mv, we can find its velocity. And also we can find the angle using trigonometry. So that was the first point. Now, second point is we look at the collision in terms of the center of mass. Now, in this question, okay, the white ball is moving towards the black ball. If they were equal masses, then center of mass will be right in the center at this position. However, in this question, black ball is a little bit bigger, has got more mass. So center of mass will be a little bit more towards the black ball. If you're asked to find the position of the center of mass, then we use the formula m1d1 equals m2d2 to find the position. But in this question, we have to calculate the velocity of the center of mass of this system of these two balls. So we use this formula. Velocity of the center of mass is m1v1 plus m2v2 and divided by m1 plus m2. So we can calculate the velocity of the center of mass. Now the principle is, so before the collision, center of the mass is moving with the constant velocity. So it will keep moving with the same constant velocity, even though these two balls move in different direction. So if we look at this diagram over here, this is the time or position where the collision happens. So after the collision, the center of mass must keep moving with the same constant velocity. So it has moved this much distance in 1 second, or that's the velocity of the center of mass. Now, so these balls, because the black ball was a little bit bigger, so its velocity is a little bit less as compared to the velocity of the white ball. So now you will have to draw this diagram and then calculate the using trigonometry. You have to calculate the velocity of the black ball and the velocity of the white ball. And remember, these one will be larger because this is in this triangle, this is the longer side, or in the top triangle, this is the longer side. So using geometry, you can find out these two velocities. I'm just going over the very brief things, but the detailed working is given in over here, and I've posted the same sheet in your Google Classroom. Now, third point of view from which we look at the collision is the law of change in momentum. And what is the law of change in momentum is? So the change in momentum of two objects is equal and opposite in a collision. So this ball was stationary, this ball was moving. So the blue ball moves in that direction and the red ball moves in that direction. So let's first of all, if we have to calculate the change in momentum of the red ball, before we do that, now, why does the momentum of the blue ball changes from 0 to a certain value? Is because during the collision, this ball applies a force on that one. At the same time, this ball will be applying a force in the opposite direction, because according to Newton's third law, action and reaction forces are equal. So change in momentum of this ball happens because there was force acting on it. Change in momentum of this ball happens because there was a force acting on the red ball because of the collision with the blue ball. So that's why the momentum changes. So let's first of all calculate the change in momentum of this red ball. So that is the direction of the final momentum. We can calculate momentum by using Fp equals mv. So that's the final momentum. So change in momentum is final minus the initial. So we draw the initial momentum in the opposite direction. It was in this direction, so now we draw it here. And so this minus that gives us this one. So using Pythagoras again, we can calculate the size and direction of this momentum. So change in momentum of the red ball is in this direction. Now, from this diagram over here, initial momentum was 0 for blue ball, and this one is in that direction. So change in momentum will be this minus that, which comes out in this direction. So what it means is that change in momentum of the red ball is in this direction, and that much size. Change in momentum of the blue ball is in that direction, and that, so they're exactly equal and opposite. So if I have to draw it, they will be like that. And sometimes they may not give you this one, and they may ask you, where does this ball go? So since we knew the change in momentum of red ball is here, we will know the change in momentum of the blue ball will be there. If this information is not given, then we can calculate the final momentum of the blue ball. So now we know the momentum of this one and that one. So, and if we have to calculate the forces, we use the impulse. Impulse equals delta P equals F times T. So using this formula, we can calculate the force. And remember, forces will be equal, but opposite in direction. So that was the looking at three principles that are kind of observed in each and every collision. Now we will look at the forces in a horizontal circular motion. Is everyone following so far? Do you hear me?
Yeah.
Okay. Okay. So now this ball is moving with the constant speed in a circular path of, let's say, radius is this much. Now, at any instant, the direction of the velocity will be along the tangent. So if it is moving like that, it will be along the tangent. And reason for that is because speed is same, but velocity is changing. So there must be a centripetal force. And in this question, they have asked you to calculate the centripetal force and the acceleration and the speed and all those ones. So let's look at to solve this type of problem, we will need to first of all look at the forces. So let's look at the forces. There are only two forces. We are ignoring the friction. So gravity force or weight force is downwards. Tension force at this particular instant will be along the string in that direction. Now, so tension force will be greater than Fg, and why it is greater, I will discuss that in a minute. But if we look at the tension force, it will have two components, one along there and one along there. Now, components are always smaller than the main force. Now, since the ball is not moving up and down, vertically it is staying at the same level. So that means this component must be equal to that one. Okay, so if we have figured out this component, we can draw another vector diagram. So that's the component which is equal to the gravity force. This is the tension force. Angles were given. So we can calculate the size of the tension force by using geometry, or we can find out the size of this force. Now it is this force which is providing the unbalanced force, or we call it centripetal force, because it's at 90 degrees angle to the motion. So it doesn't change the size of the speed. It only makes it change direction and go in a circular path. So these are just the basic principle, but rest of the details of the question you can find out in the answers. Now, cars around the bends, they follow the same principle, because this car is moving. So it is like and it is a banked surface. So the road is banked at an angle like this one. So this car will be moving in a circular path. If we have a bird eye view, it will be like that, similar circular motion. So this one from here to there will be the radius of the motion. So again, to solve these problems, we will draw the forces, which will be similar to the forces that we did for the conical pendulum. So gravity force or weight force always acts downwards. Support force will be at 90 degrees angle to the road surface. Now, friction force, to keep this question simple, we're assuming that there's no friction force, but if there was a friction force, that will be along here. But in this case, there is no friction force. So these are the only two forces. Now, since this car is moving the same vertical position, it's not going up its path or kind of slipping down its path. So therefore, these two forces are equal. Fg is equal to F1. And what is F1? F1 and F2 are the components of the support force. So if we know this one, because we know Fg, then using geometry, we can find out either the support force or this force. So this is the unbalanced force, which is at this instance, towards the center of this motion. And that is providing the centripetal force. So using this one, this is the same kind of triangle. I have taken it out here. So we can calculate the value of F2, and F2 will be the centripetal force. Now, what happens is, if, because of the angle, support force will have certain value. So that means this one will have certain value. So car can go at a certain speed. It cannot exceed that speed, because this force is constant. So if car goes at a speed which is faster than which makes this force more than the force provided by the support force, then car will not stay along the same circular path. It will go along the tangent. So that was the circular motion, horizontal circular motion. Now, Now, gravitation and satellite motion, they also follow the same rules. The centripetal force is mv square over r. But in this case, forces will be a bit different. So if you look at this diagram, do you all see this little diagram? There is an Earth here and there is a satellite here. Would anyone answer, please?
Yeah, we can
Yeah.
see it.
Yeah.
Okay. Now, this is not to the scale, but this is the Earth. A person is standing on the Earth. So what I want to show is that there's a gravity on this person, and this gravity is more than the gravity on the satellite. And reason for that one is because gravity at any position is proportional to the mass of the Earth and the distance from the center of the Earth. So for satellite, radius will be from here to there. So therefore, because it's a bigger radius, so gravity will be smaller for this one as compared to one on a person. Like on the Earth's surface, we have got about 9.81. This will be much less. This gravity, which is 9.81 on the surface of the Earth, is also called centripetal acceleration. Another formula that we know that centripetal acceleration is v square over r. So these are the two formulas. Now, gravity is different from the weight force. So gravity over here is 9.8. Force will be mass times this one. So if we want to find out the force on the satellite, so this satellite is going round and round. And what is keeping it in its circular path is the force of gravitational force, which is towards the center of the Earth. And that gravitational force will be equal to G. G is a gravitational constant, mass of the Earth, mass of the satellite, r square. And so this is the gravitational force, and this force provides the centripetal force. So we can calculate, if we are given the speed, we can calculate the force, or if we are given the force, then we can calculate what should be the speed of the satellite if it is at a particular radius from the surface of the Earth. Now, another thing is the period. Period of the motion is that formula, v equals d over t. So that's the period. So period will be 2 pi over v. Now, a geosynchronous satellite is the one that has got the same period as the spin of the Earth. Now, spin of the Earth, the period is 24 hours, which that can be changed into second. So for this one, satellite, it will have the same period so that it always stays at the same position for all the, the communications between different cities and countries and all that. So again, using the same equations, we can use or calculate these type of problems. So that was also an example of horizontal circular motion. Is everyone following so far? I'm just going at just giving you a brief summary. And do you hear me, guys?
Yeah.
Yeah.
Okay. So now we will look at the vertical circular motion. So plane is flying like that in a vertical circular motion. Like we have roller coasters and you go up and down like that in a roller coaster ride. Now, in a horizontal circular motion, speed is constant. But in this one, speed will be different at different positions. So we will look at the forces and the speeds at different. So let's look at the forces at the bottom first. Remember, plane is flying in this direction, like in a vertical circular motion. So gravity force is downwards. There will be lift force from the engine. I've written is support force, but it is the lift force. In case of if there was something like like you have some stone or something and you're spinning it around in a vertical motion, then that will be called the tension force, or general word is just the reaction force or support force. Now, because this object is moving in a circular motion, so there is a centripetal force. So that means that centripetal force is provided by this lift force. So this lift force has to be greater than that one, because not only it is balancing the weight force, but it is supplying centripetal force for the circular motion. So unbalanced force will be F sport minus Fg. which is written somewhere over here, F support minus Fg, and that's the unbalanced force or the centripetal force, and it is mv square over r. So if we are given the force and all that, we can calculate the speed, or if we are given the speed, we can calculate the force. Now, generally, what we feel is the support force. You know, like you're sitting in your seat, so you're feeling normal. But if you were in a plane like over here, and you were at the bottom of the loop, because support force is greater than the weight force, so you will feel heavier at this position. So these were the forces at the bottom. Let's look at the forces on the top. Now, because plane is now upside down, so the lift force is downwards, okay? And so is the gravity force. And together, they're providing the unbalanced force. The gravity force here will be same as with the gravity force there. It doesn't change. But the support force can change depending on the speed. So these two together are equal to the Fg plus F support is the centripetal force, and that is mv square over r. But what happens, let's see, if the plane decreases the speed. If plane decreases the speed, Fg wouldn't change, so this will become smaller and smaller until, so when it becomes 0, that's the minimum speed that the plane must fly at. If its speed is less than that, then motion will collapse. It won't be able to keep into that circular path. So what happens at minimum speed is that F support becomes 0. So if we make F support 0 in this equation, then F support becomes 0, or Fw is equal to mv square over r. And if you equate this equation, minimum speed becomes gr. Now, another thing is, over here at the top, if you were a pilot in this plane, what you experience is the support force. Okay, so if support force is less than Fg, you will feel lighter. Okay, and if this support becomes 0, then one will feel weightless. There will be no, it will be like, weightless situation like in a space. So these were the forces in a vertical circular motion. And the last thing, which I wouldn't spend that much time, is we will be looking at the energy. So say, for example, an object, and we're looking at like a roller coaster ride. So, for example, it could be a cart, or it is just a ball or something. At this position, if it's stationary, all its energy is in a form of gravitational potential energy. As it comes down, it changes into kinetic energy. And let's assume there is no friction. So at the bottom here, all its energy, at the very bottom here, all its energy will be equal to the gravitational potential energy that it had here. Now, as this cart or the ball rolls up this vertical, like roller coaster loop, it's upside down here. Now, at this position, because it's moving, so it will have kinetic energy. And because it's higher than the ground level, it will have gravitational potential energy. So it will have two energies, gravitational plus kinetic, and together they will be equal to the total energy that it had here. So to find out, if we are not given this height, quite often in the question, they will give you the distances and all that, and you will have to first of all calculate the minimum speed. What is the minimum speed this object must have? If the speed is less than that, then it will collapse. It won't be able to stay on the path. So minimum speed from the top question, we found out that it is gr square root of that. So using this equation, we can find the minimum speed. And then using this equation, we can find the kinetic energy. If that's the radius over here, then height from here to there will be twice more. So we can use this equation to find the gravitational potential energy. So once we found the kinetic and gravitational potential energy, we can find the total energy. And if we were not given this height, then whatever the total energy is here, we can calculate the height, that what height should the ball be released so it is able to stay in that vertical loop. Now, so that was all about the vertical loop and conservation of energy. But let's apply this one to a little bit situation that could be asked. So like there is a hump, on the next path. So the object is on top here. So now this is different from the vertical forces that we looked in the top question, because it's not inside, it's on top of the loop. So gravity force will be acting downwards. Support force from this path will be acting upwards. Now, if it is a vertical loop, that means unbalanced force or centripetal force will be downwards. That means gravity force will be greater than the support force, or in other words, support force at this position is smaller than the gravity force. And that's why you might have noticed, if you're going on a hump on a road at a quite faster speed, at the very top of the hump you feel lighter, you feel something in your stomach, and that's sensation that you have because you're feeling lighter. So support force will be smaller and gravity force will be more. And again, if we want to figure out the sizes, we will do Fg minus F support will be equal to unbalanced force, that's equal to mv square over r. Okay, so now question in the sheet is a little bit different, but it is similar. Instead of coming down a slide, it is just a straight motion. So all the energy here, which is kinetic energy, will be same here as the initial energy. So this is all about, just we have covered is almost everything that we've done in the linear motion, not in rotational motion and simple harmonic motion. So I think that is quite long enough for you to focus for that long time. So I will stop sharing the screen. Okay. Now, is everyone okay?
Yeah.
Yeah.
Okay. Okay. So any questions? I will stop recording it so you can